In lesson 10.1, we are going to be talking about the area of quadrilaterals and triangles. Parts of this is going to be review and parts of this is going to be new for you. Hopefully you remember that the area of a rectangle is given by the formula base times height, or you could think about it as length times width. Well, if you look down below, you can see that the figure I have outlined here isn't a rectangle, but it is a parallelogram. And so if we thought about finding the area, remember the area is the space inside, and we wanted to know what formula that would be. Well, if I took and split this parallelogram right here, and I have this triangle, if I rotated it around to complete this figure here, I would end up with a rectangle. Therefore, the formula to find the area of a parallelogram is the same as finding a rectangle. It is going to be base times height. So down below in my formula box, I'm going to say that capital A is base times height. If you look here, they are showing me that if I have my base B of my parallelogram, my height would be this dotted segment here. It is not the slanty segment. The height has to meet the base at 90 degrees. Now, this line could be shifted over. It could be right here. This would also be a height or an altitude because it would meet one side at 90 degrees. I could also put that line right out here. And this would also be the height of the parallelogram. But just knowing that it has to meet the base or a side containing the base at 90 degrees. It has to be straight up and down. So let's look down below. Sometimes when you are given your figures, you're going to be given some extra information or numbers that you're not going to use, which would be the case in example A, figure number 1. I know that to find the area, it's base times height. In this case, my base of 5, my height would be 4, and I would not be using the 4.5. That would come into play if we were finding perimeter. Now, when we find our area, 4 times 5, we know that that's 20. Remember that it is labeled in units squared. This is 20 square units. What is the difference between, 20 inches squared? What is the difference between a square inch and a linear inch? Well, when I take a second and look at that, if I have 1 linear inch, it is like this. That would be perimeter around linear inches. But a square inch would be something like this, where I have 1 inch by 1 inch square. So I'm thinking about how many of these it would take to fill up my figure. So that's why our label is important. 1 square inch is very different than 1 linear inch. And I'm going to be particular about your labels this chapter. Now, as I look at example number 1, the second figure, would you agree the parallelogram here, if this side is 11, this is 11, but my height is not 34. So I could not take 11 times 34. In fact, at this point, I don't even have enough information to figure out what the height of my parallelogram is. If I had a little bit more as far as my measurements go, I could probably figure out that height. Sometimes you might see your figure drawn as so. My height would be this dotted line. And let's just say that I'm going to tell you from here to here would be labeled as 30 millimeters. Now, if I were going to figure base times height, I could use the Pythagorean theorem. A squared plus b squared equals c squared because I have my right triangle. And if I calculated that, we would actually find that our height would come out to 16. How would I find my area? Well, the base of my parallelogram, would it be 11? Would it be 30? Or would it be the whole segment of 41? Right. The dotted line would not figure figure into the base, my base that I would use would still be 11. So this area, we would simply take 11 times 16. 11 times 16, we would find out that we would get 176 square millimeters. Okay, down below, sometimes they're going to give us some questions similar to on our worksheet where we may have some x's or y's or variables in our numbers. It asks number 2 to find the perimeter of the rectangle if my area is 12x square feet and one side measures 6. Well, sometimes I like to give myself a picture. If I have my rectangle and the area is 12x feet squared and one side measures 6. Well, in order to find the perimeter, we're going to need to know what this missing side is here, right? Well, we know it's base times height. If I just take and divide 12x by 6, what are we going to be left with? Yes, this side would be 2x. So perimeter would mean that I'm going to take and I'm going to add up all of my sides. 2x plus 6 plus 2x plus 6. Here, we are just going to simplify as much as we can by combining our like terms. I'm going to have 4x plus 12. So my perimeter is 4x plus 12 feet. It's a linear measure. Sometimes you'll see they'll put the parentheses around just to separate the number from the label. It is not going to change my answer at all. It just simply separates it. I won't count it right or wrong based on your parentheses, whether you have them or not, but I just wanted to explain to you that it doesn't change the answer. Let's look at one more. In example A, they want us to find the perimeter and the area of this parallelogram. Well, as I look at this, the perimeter, if this is a parallelogram, should be pretty easy because we already have the numbers that we need if we simply add up the distance around our figure. So if I add 30 plus 15 plus 30 plus 15, we are going to end up with a perimeter of 90 feet, right? That's a linear measure. That's all I'm going to do for that one. Now my area is a little bit trickier because I need base times height. And it looks, my base is 30, but it looks like we don't have a measure for our height. However, I see here that I have a 45-degree angle in this corner. And if this is 45 degrees, this angle up here is 45 degrees. If I have a right triangle, I can go ahead and use my trigonometry. Here in my right triangle, I know this would be the hypotenuse, and I know this would be the opposite. So we can go ahead and calculate that by saying the sine of 45 degrees would be opposite over hypotenuse. Looks like we're just going to multiply 15 times the sine of 45. We are going to have to round that off, so we're at least going to round it to the 10th, and we would find we get about 10.6. Now I can find my area. I know area base times height, so we are just going to take 30 times 10.6. Multiply that, it does come out nice to 318 square feet. Now hopefully you remember the formula for the area of a triangle. Formula 1/2 times base times height, or you may have learned it as base times height divided by 2. Either of those would be fine, they mean the same thing. Why is it the 1/2? Well, really it's half of a rectangle or half of a parallelogram. If you draw in the diagonal, into your rectangle or parallelogram, you have two triangles. And so that's why it's half base times height. What about our trapezoid? The trapezoid may not be one that you remember off the top of your head, but it looks like this. 1/2 parenthesis B1 plus B2 parenthesis times height. What does the B1 and B2 stand for? Well, that stands for the base. The bases of my trapezoid have to be parallel. That's how you know which ones are the bases. And again, my height has to meet at 90 degrees. The reason it's 1/2 times the quantity base 1 plus base 2 is because we're actually taking those bases and averaging them out. If it were a rectangle, we'd do base times height, but since they have different lengths, we average them first, and then we times it by the height. So if I take a look down below, simply finding the area, sometimes we have to do a little bit of calculating in order to have all of our information. We know that if our triangle here, 1/2 base times height, well, our base and our height are not the 12 and 13. If I use 12 as my base, I know that here I need to look for h, my height. Just so happens that I can do that because I have a right triangle. And so in this case, I'm going to use my Pythagorean theorem to figure out that height. I'm going to say that h squared plus 12 squared equals 13 squared. 13 is my hypotenuse. And hopefully you all remember solving the Pythagorean theorem. If I subtract here, I'm going to get that h squared is 25. So if h squared is 25, then h has got to be 5. So what am I going to do to find the area of my triangle? Well, now we know base of 12 and a height of 5. And the big thing is you can't remember, or don't forget that we are multiplying by half. Well, this is 60. Half of 60 is 30. So my area here is 30 square centimeters. What about picture number 2? My area, 1/2 base times height. What am I going to use as the base of my triangle? 10? 4? 14? Well, my triangle is just this part right here, right? The dotted line is not part of the triangle, so that base is 10. But my height, well, the height, because this is obtuse, it does show from top to bottom would measure 6.4. And so that is going to be the height of our triangle. So it's okay sometimes if the segment is shown outside of the triangle. Multiply those together and you should find that our area is 32 square feet. Finally, I have number 3, my trapezoid. Looking at my trapezoid, I know the formula. We're going to take 1/2 times the average of the bases. Which sides are my bases? Well, the bases are the ones that have to be parallel. So they are going to be the 20 inches and the 36 inches. In this case, I actually have this segment here meeting at 90 degrees. I can use a height of 18. So when I fill this in, I do have to remember that we are going to follow order of operations. And so I'm going to add these together before I multiply by half and by 18. And so this is actually 56. And then we'd multiply our numbers together. In the end, you should find out that we are going to get an area of 504 square inches. Sometimes they're going to ask us to do a little working backwards, like number 4. It says the base of a triangle is 4 times its height. If the area of the triangle is 242 square millimeters, find its base and height. I always recommend you to draw a picture just to give yourself kind of a visual. My triangle base, I know then that this would be my height. The base of the triangle is 4 times its height. Well, I don't want to use b and h because I don't want to have two different variables. But if I said here the base is 4 times the height, I know the base is the bigger segment. So I could think about my height as being x units long. What would that mean for the base? It's 4 times that. Now it did tell me that my area was 242. So we're going to use that. If I have area equals 1/2 base times height, I'm going to say 242 is equal to 1/2 base times height. Now the question is, how do I simplify? Well, I don't distribute. This is three things just simply being multiplied together. I can think about taking half of 4x. What's half of 4x? Well, yeah, it would be 2x. And then I'm going to multiply it by x. Well, x times x, remember you add the exponents. This would be 242 equal to 2x squared. Again, I'm still solving for x, and so I want to think about getting x by itself. I'm going to get rid of my 2 by doing some division. $121 equals x squared. In order to undo my x squared, I'm going to do the opposite, which would be the square root, and we would find out that x is 11. Okay, where do I go from there? Well, you ask yourself, what is x? Well, in my picture, x was the height. And so as I list my answer, I know then that my height would have to be 4 millimeters. And my base is 4 times that. So my base would have to be 16. Let's take a look at number 2. I have a trapezoid. They actually tell me the area of my trapezoid, and I'm solving for base 2. So again, I'm going to plug in what I know and do some solving. My area is 231. 231 equals 1/2 parenthesis base 1, which we know is 23, plus base 2, which that's the variable we're looking for, times the height. Now you could go about solving this a couple different ways. But what I have to do is I have to leave the parentheses for last. So if this is 1/2 times this quantity times 11, a lot of times people like to get rid of their fraction first. If I want to get rid of my fraction, 1/2, it's being times by 1/2 times the rest of this. So I could undo that by dividing. I could also think about multiplying by the reciprocal, which would be multiplying by 2. 231 divided by half is really 231 times 2, because that's the reciprocal. And what am I left with? I'm left with this. So now what do I do? Well, again, I'm working backwards. I got to get rid of my 11. When you solve these, you kind of work the order of operations backwards. Now, I'm left with this. The parentheses really don't mean anything. It's 23 plus B2 equals 42. So we simply need to know what we would be left with after we subtract. And we would find that our base 2 is equal to 19 millimeters. And of course, we always want to ask ourselves if our answer makes sense. In this case, 19 seems reasonable. We're also looking for a linear measure, so I'm not going to label it squared. It's just simply 19 millimeters straight across. Moving on to the last part. These you may not be as familiar with. You may not remember the formulas, but for a kite and a rhombus. Remember, a kite has two sides that are congruent, two sets of sides congruent, but those sides are consecutive. Well, here's the formula to find the area. 1 half times D1 times D2. What does D1 and D2 stand for? Stands for the diagonal. And the diagonal is all the way across from one corner to the other. And actually, for a rhombus, it's the same formula. 1 half times D1 times D2. But keeping in mind, a rhombus is also a parallelogram. So depending on our information, I could also use the base times height. Depends on what you're given. Now, as you look at example C, number 1, they tell me that I have a kite. And so when I'm looking at the area of my kite, I know it is 1 half times diagonal 1 times diagonal 2. What numbers go in there? Well, my diagonal, as I said, all the way across, we need to add those together. 24 and 24 would mean a diagonal of 48. And 18 and 10 would mean a diagonal of 28. And again, I'm just multiplying these three numbers together. So check that out. Multiplying together, you should find that you get 672 square feet. If I were asked about finding the diagonal, like in number 2, I have one of them. I have my total area. I would simply be working backwards. 238, my area, would be equal to 1 half diagonal 1 times diagonal 2. Well, this is all being multiplied, so I could just think about dividing. Or, I know what half of 14 is. Half of 14 is 7, so I could simplify a little bit before I divide. 238 divided by 7, and we would find that our diagonal 2 is 34 inches. Okay, let's take a look at the last one. The last one asks us to find the area of my rhombus if D1 is 2x plus 2 and D2 is x plus 3. Okay, well, let's fill in what we know. Area is 1 half diagonal 1 times diagonal 2. Now, I'm going to end up having some x's in my answer. I'm going to have an expression. The first thing that we're going to think about doing is let's go ahead and simplify by distributing my half. Now, my 1 half is being multiplied. I actually only distribute it to the first quantity. So this is going to end up half of 2x and half of 2 would look like so. But I still need to then multiply by x plus 3. What is that going to require us to do? Right, we are either going to need to FOIL or we need to box. Okay, so if I'm going to take a look at foiling, I'm going to do my first terms, x times x, my outside, x times 3, inside, x times 1, and then my last terms, 1 times 3. And like in most cases, I can do a little bit of simplifying. I'm going to give my final answer as x squared plus 4x plus 3. This is area, so this would be in units squared. Now, again, I might put parentheses around there just to separate my answer from my label, but I don't have to. Okay, so at this time, I would like you to now work on completing your worksheet for 10.1. If you have questions on this, you need to please plan to come and see me before school or during SRB.